Now a threshold alert system. The daily briefing tells you where things stand. The alert system tells you when something's wrong. Immediately, not at the next scheduled report. Not when you check your email, when it happens. This is the difference between a morning report and a smoke alarm. The architecture is different from build number 1. Build number 1 runs on a schedule. Every weekday at 7:30 a.m. it fires. Build number 2 is event-driven. It fires whenever a new file arrives. A bank file lands in the shared folder, the workflow starts instantly. Claude checks it against thresholds, and if anything is below minimum, an alert goes out. Let's walk through it. So now our next automation is going to be our cash movement alert. Again, following the same format, we're going to have our trigger. We're going to set information we need. We're going to work with the data. That's this section right here. We're going to have our AI agent. It's going to output, and then it's going to distribute. So always that same format, even if the nodes are slightly different. And what we want this to do is anytime there's an update to our banking information, which in this case is set on Google Drive. Now you can connect this to an ERP, you can connect this to QuickBooks, you can connect this to whatever you want, wherever your freshest banking data will be. Some banks might even allow you to API and look at your accounts. If you have any of those options, you can connect to that and always get the freshest information so that this will constantly be scanning. So now this cash movement alert, we're getting hourly updates during the working days on our banking information. It goes into Google Drive. So we're saying we want to run this every single hour. So we'll go ahead and kick that off. Because this is a constant monitoring alert, we want to run this frequently. You could set it up to run more. Of course, just keep in mind every additional run, more tokens, more expense for your computing. Could be worth it if you have a lot of transactions. For a 3-chain coffee shop, hourly is totally acceptable. Now we're going to go to edit fields. Again, we're going to point it straight to a file on Google. So here's our source folder ID. If I come over to Google, you'll recognize the same ID here. And these are our live balances. The ERP is simply These are our live balances. It's easier in this case for the ERP of the F9 Finance coffee shop to just send the balances to the Google Sheet every single hour versus connecting NAN straight to it. A lot more security parameters. So it's connected right here, and we're setting that folder. So we'll go ahead and execute that step. That's now set for the workflow. We'll go to search files and folders. Same as before. We're going to look for everything in that folder. We're going to pull in the IDs. There they are. There's the ID. There's just one file in this folder, our live balances. We're going to download that file. So far, very similar to our last process. We're again going to extract the data. We're going to run code. Again, all of this code from Claude Code, which you now have the skills to run. Any questions as you go, I'll keep saying it, just ask Claude. Now we'll execute this step. It's going to clean up our data. You'll see this is called AI payload, meaning we've got 12 balances. I'm going to feed it in a single string so AI can process it cheaply and efficiently since we're running this so constantly. The AI agent, again, we've got the chat model attached down here. That's our Anthropic Claude Sonnet 4.6. Honestly, for something like this that runs so much, we could even use a slightly lighter model, but we'll leave it there for now. I come up to the AI agent. Again, the AI payload is there. We don't need memory on this. We do have a tool. We want it to be able to think about any of the issues. So this tool is thinking. I come down to this. This is to just think. This allows us to use complex reasoning or some light memory to kind of build a memory cache so we can do more processing and think through the balances and make sure that we're flagging things that need to be flagged and not flagging things that don't need to be flagged. Because this is running so frequently, we don't want it going crazy or our email is just going to blow up. We want the right things called out. And then the prompt, again, prompts that we've built out earlier in this course in Claude, we're copying and pasting here. It's already the whole thing tying together. And now this is our AI one, so this will take a little bit longer again. We'll go ahead and execute this and let Claude do its magic entirely on the back end. And remember, you're watching me manually kick these off because I'm showing you how to construct this and how it's put together, but this will run every single hour without any intervention. You don't need to open up end-to-end unless something breaks. It's just going to keep running every single hour, monitoring for issues. And as you'll see in a second, if there's no issues, you won't even know it's running. It's only when there's an issue that you're going to find out it's moving. All right, and here's our output. It looks like we might be getting some stuff back because I see that there's a critical alert coming out. You can see everything a little bit easier in the table down here. Looks like we've got some missing thresholds and some negative balances. Here's the JSON. All right, now we'll move ahead. So this is saying if the decision status is equal to an alert, which it looks like decision status alert, there's a problem. So if it's not an alert, if there's no issues, this is going to just stop and nothing's going to happen until the next hour when it runs again. But because it's an alert, it's going to proceed down the node and it's going to send a message. So we'll go ahead and execute this step. This is going to send an email. We have an email subject coming from the agent, and then we have the message coming from the agent as well. We'll go ahead and execute this step. It's going to send off the email. Now we're coming over to our email, and here it is. I think it's pretty obvious that there is a critical alert here, critical 13 alerts. So we're seeing there's a breach type. Some of our thresholds are missing. So we don't know if there's a minimum or maximum balance. The severity of these is a warning. This one, however, is a negative balance, and it's found to be critical because it's negative. So clearly, regardless of the threshold, we know that this negative is a problem. It's also flagged here. It is a missing threshold. It has the same issue, but this is the same item, and it's flagged the critical warning that there is a negative balance. So that's where that thinking comes in. It can see that what really matters here is the negative balance. Everything else, we have to go fix the thresholds missing, but we really want to focus on the negative balance. And then it also gives us recommended actions. And this whole email built, formatted by AI, and processed by n8n. Again, the work, the real work and the thinking and the processing is being done entirely by Claude. No different really than working with the chat. n8n's just gluing this all together so you don't have to get the data, so you don't have to kick it off, so you don't have to process anything, even writing the email. Now our third build, the compliance check. The compliance check in Module 3 was manual. You pulled the positions, you read the IPS, you checked each position against the 5 guiding principles, you flagged exceptions. You wrote a report. This build makes it weekly and automatic. Every Monday morning before the controller even opens their laptop, the compliance report is already in their inbox. The workflow runs early, 6 a.m. before the team starts. The report is ready when people arrive. And now it's time for our policy assistant. And this one is going to look completely different, but also completely the same. So just like before, we still have triggers. We have 2 triggers in this case. So we have a trigger here that's manually executed. We'll talk about that in a second. And we have a trigger over here that's based on when a chat message is received. I can open a chat window, and down here we have a chat window just like we would have in Claude. Then we've got the data, and the data is in 2 places. So the data is here and the data is here. And again, I'll explain that in a moment. Then we've got the AI agent, which is processing, and then it's just sending information back to the chat as the output, as the communication, as the distribution. All the pieces are here. It just looks a little bit different. Now, this is a 2-step workflow, and there's a reason for that. Remember, we've got our investment policy statement, right? So if I go here to the download file, you'll see we have this folder here. So if you come over to the Google node, you'll see we're pulling this specific file by ID. Now, why would we do a specific file when I said we want to make sure this is dynamic? Well, because that specific file is our investment policy statement, our key piece of information for all of our policies. So I'll exit out here for a second. So what this is doing, this is going and getting our investment policy only when we execute. This is just sitting here waiting for a user to come in and say, hey, the investment policy's changed. This never needs to run except when there's a new investment policy. Once there is an investment policy, it puts this into something called a vector store. Again, you can ask Claude at a high level. A vector store disassembles content into tokens so that AI can read and process it faster. It organizes the tokens in a way the AI can understand. So we're taking the policy document, we're putting it into that vector store, into that easy to read format, we're embedding it in the vector store, and then that gives our agent the ability to ask us questions. So we're essentially building a database for our AI tool to then be able to ask questions about our policies. And this whole process only needs to run when we have a new investment policy statement. Then when you come over here, it's just the interaction back and forth with the chat. So you've got your AI agent. It's working with memory, it's working with the chat model, and it's working with the database to answer questions about the policy. So this whole setup over here loads the policy as needed. this whole setup over here calls the loaded policy that's designed to be used by AI easily to answer questions. So quite a different setup, but again, also still the same. So walking through this step by step, this execute one is easy. It only executes when you hit the button, because again, this will change probably no more than every 6 months, if not even every year. So that's run. We now come here and we're going to pull this specific file. So this step is going to go in. It's going to pull in our investment policy PDF. So we've got all of our pages over here, our 8 pages, the same one we've been working with in our other examples. We'll come back over here, and then it's going to go into the vector store. So we have the vector store key here. So we have a vector store key. Because we're working with one, we can just have vector store key. And again, any questions, ask Claude. And what we're going to do is we're going to insert documents, which is going to be the documents we're providing it. With that, we're going to use an embedding agent. So here I've got the OpenAI embedding agent, just because I've found that the OpenAI embedding agent actually works quite nicely and a little bit cheaper than Claude. So we're using that there. And then we've got, and then beyond the embeddings, we've got the document loader. So AI tools don't know exactly how individual documents need to go. So what we've got here is this document loader allows us to take the PDF file and convert it into a format that can be vectorized and stored. So you'll see here I've said the data format is a PDF. The text splitting is simple. Now, I had not worked with a default data loader before building this. I had Claude explain it all to me and help me step by step build this out. And it told me every single field to fill out. So this is just helping us load our vectors. That's this process. It's taking in our new file, it's loading it in a format that can be easily understood, and then by connecting the embeddings, we're allowing it to be fed to this vector store over here. Now, for our right side, this kicks off anytime a chat message is received. You can even make N8N chats publicly available, or you can make them available to your team, or you can put them in your N8N chat hub that I showed you, the new feature. And you can have all of the conversations back and forth there. It's going to work just like talking to Claude, but in this context of your policy document. Now from there, we've got our AI agent. The AI agent is connected to an Anthropic chat model. It's also connected to simple memory, just so it can remember the conversation. If you don't have memory, it will only remember the current chat. I've given it the ability to have 10 interactions. Now keep in mind the 10 interactions is both you and the model. So if you say something and it says something, that's 2, not just your 1 interaction. Now, every single interaction is sent to the Claude model, meaning you're paying for it and paying for the tokens. And we don't want to go crazy with that. That's why I've limited this to 10. That's usually enough to answer a policy question, but not enough that you're just burning tokens, sending them back and forth to Claude. Then the last item, again, we mentioned the vector store. This is where all of the data is saved. So we have the same vector store key we saw before. The name of the key doesn't really matter, just has to be the same one that you built. And this is designed to retrieve. So the other one is embedding in the vector. This is retrieving from the vector store. And then it's as simple as chatting. So I can come down here, and instead of this being a scheduled or a kicked off workflow, I just ask questions. So let's go see a good question, because if you remember the prompt we built earlier in the Claude sections, we had a lot of guardrails about how you have to cite specific information. So let's go ahead. Here's a good question. I'm open to it. Approval authority. So what approvals are required on debt? So we'll come over here and say, what approvals are required if I want to issue a term loan? All right, so we'll send that away, and what we're looking for is for it to cite that specific section that we just referenced. Now you'll see as things run, once they're done running, they go green, and as they're running, you see this kind of red circle. Right now, the chat model is running, and the AI agent is running, processing our question. Once it's done, it's going to feed back to the message. There it is. So let's scroll up so we can see the whole thing. I can just pull this up a little bit. There we go. Pull this up. Term loan approval requirements. We have to confirm it's a permitted use. All right, we have the base approval. CFO approval is required for every new debt facility. Yes, it is. No single individual. Let's see, there's thresholds. Here's exactly our thresholds, all cited and referenced from 7.3. And then we have authorized financial institutions. We didn't even ask for that, but it was able to find that and pop it in. And then here's important restrictions. So it nailed it. It used cited sources. Everything ties right back to the investment policy. And you can just ask questions to your heart's content about your business. Now, this is also a good place to mention, since we've got the chat open, this is also where you have logs. So every single thing that runs in your N8N instance is stored. This is an overview. So these are all the runs. You'll see these are the cost of tokens. So to run this model so far, we've spent just under 30,000 tokens. You'll see here the prompt was 9819, completion 61. Here the prompt was 18,000 and the completion was 544, and that's how we're paying Anthropic. So this cost money as I click the button. So don't go too crazy on this, right? But every single run is here, and then you can click on any individual log and you'll see all of the inputs and the outputs, and all of these are saved in here so you can audit wherever anything is coming from. And it really is that simple. With that, you've just built an entire AI agent that you can have conversations with about any of your company policies or anything else you want to throw at it. Now notice all three builds follow the same pattern. Trigger, get data, call Claude, format and distribute. Different triggers, different data, different prompts, but the same architecture. Now, some common questions I get on API automation. First, what if the bank file format changes? Well, in that case, build field mapping with fallbacks into your workflows. If the column name changes, the workflow checks for alternative names before failing. It's also important to monitor your error logs at least weekly. A format change will surface there immediately, and you can update the prompt to handle the new format. The next question, does Claude see our bank data? Is it secure? And the answer is yes. Claude sees the data you sent. Anthropic stores API requests for up to 30 days for security and compliance. For highly sensitive data, consider a self-hosted N8N setup with Claude API access limited to your network. This gives you full data control. Next, what happens if the API is down? If it's down, N8N will retry the API call. If it's unavailable for an extended period, the workflow will time out and trigger an error notification. You'll know immediately when that happens. Anthropic also publishes API status at status.anthropic.com. Now, can we modify these workflows for other use cases? Absolutely. What I want you to focus on is the pattern, because the pattern holds for any data source and any prompt. You could do loan portfolio analysis, vendor invoice reviews, customer correspondence routing. They all follow the same trigger, get data, call Claude, format, and distribute structure. Now, how do we audit that these workflows ran correctly? Well, N8N keeps a complete execution log. Every run, successful or failed, is timestamped and recorded. You can export this log for compliance and audit purposes. For Treasury, this is your automated workflow audit trail. Now, what about cost? Can we set spending limits? Well, yeah, Claude API pricing is based on tokens consumed. For these Treasury workflows, you're typically looking at cents per run. Daily briefing, maybe 2 to 3 cents. Alert check, 1 to 2 cents. Weekly compliance, 5 to 10 cents. Month-long cost will usually be 20 to 30 bucks. N8N and Claude can have ways for you to set spending caps. You can also request higher rate limits or discounts if you're processing significant volume. By the time you finish this module, you'll understand that pattern deeply. You'll be able to build new workflows using it, new data sources, new prompts, different objectives. Same underlying structure. Now, the next lesson is about what happens when these automations break. Because they will. That's normal. That's why we cover troubleshooting and error handling. Automations break. That's not a failure of the tool. It's the nature of connected systems. Bank files come in late. Field names change in an ERP export. The API returns something unexpected. The email server hiccups. Knowing how to handle this is as important as knowing how to build it. Now let's walk through the common failure modes you'll run into with Treasury-specific examples. First one is late or missing files. The bank file didn't arrive by 7:30 a.m. The workflow fires, looks for the file, can't find it, and errors out. The briefing doesn't get sent. Maybe you don't notice until afternoon. The fix here is to add a check step at the start of the workflow. If the file isn't there, send a file missing notification instead of letting the workflow fail silently. That way you immediately know that something's wrong with the data arrival. Change field name. Your bank changed the export format. The column was called account name and now it's a act name. The script that reads it breaks. Claude gets the wrong data or no data at all. The fix here is to build field mapping with fallbacks. Tell the workflow, first look for the column called account name. If that doesn't exist, look for names that are 80% related. With fallbacks, one small format change doesn't blow up the workflow. Now, how about an unexpected Claude response? Well, Claude occasionally returns something slightly different than what you expected. Maybe it wrapped the JSON in extra text. Maybe it used different field names. If your workflow tries to parse a field that isn't there, it fails. Now, the fix here is to add error handling to the Claude response node. If the response doesn't match the expected structure, log the raw response and send a notification. This way you can see exactly what Claude returned and understand why the parsing failed. Setting up error notifications is absolutely essential. Every workflow should have an error trigger attached. When anything breaks, end-to-end sends an email or Slack message. This is not optional for production Treasury workflows. You need to know when things break. You might not notice on its own for hours, but an alert will tell you in seconds. Now, end-to-end keeps an execution log. Every run, whether it's successful or failed, is recorded. There's timestamps, input data, output data, and error messages if there were any. For Treasury workflows, this is the audit trail. If someone asked, did the compliance check run last Monday? The answer will be an end-to-end's execution log. If there was an exception, what was it? When did it happen? All of that is logged. Now, testing changes is essential. Never modify a live workflow directly. Make a copy, test the change against sample data, verify it works, then swap in the live version. This protects you from breaking something that's actively being used. Treasury can't afford downtime on automated alerts. Now, when should you rebuild versus when should you patch? If a small field name changed, patch it. If the bank changed their file format entirely, rebuild the relevant section of the workflow. If the workflows become hard to maintain because you've patched it 5 times, rebuild from scratch with what you know now. The work compounds. A fresh build is sometimes cleaner than a heavily modified old one. And one more thing, update your prompts when the data changes. If the bank adds a new field to the export, update the Claude prompt to acknowledge it. If the IPS gets revised, update the compliance prompt. The prompts are living documents. Your workflows will only be as good as the instructions you give Claude. Troubleshooting is a skill. It takes time, but automated Treasury workflows are too valuable to let fail. Once you've built them, you protect them. Now that's the end of Module 6. You've learned the API, learned end-to-end, and built 3 automations. Module 7 is about bringing all of this up to the standard a CFO or controller would expect before signing off. Controls, governance, production readiness. That's where we take these builds from learning projects to real systems.